APPL can be used to find the distribution of transformations of random variables. And here is a familiar example that was worked out analytically earlier in this section. Let the random variable x be uniformly distributed between 0 and 1. Find the cumulative distribution function of y equals g of x equals the square root of x. In this particular case, we know that the probability density function of x is 1, defined on the support 0 is less than x is less than 1. And this first APPL statement here, x is equal to, and here's the list of 3 lists, defines this probability density function. It will be 1 between 0 and 1. X is a continuous random variable, and this 1 right here is a probability density function. That's consistent with what we have here. The second thing to do is to define a function g, and in this case y equals g of x is the square root of x, and that's done by a list of 2 sublists. The first gives the transformation, the square root of x, and the second sublist gives the values, and that is the values between 0 and 1, where this transformation can be applied. The next step is to determine the distribution of y, and there is a transform function that has 2 arguments. The first is the random variable that's being transformed, and that is x. And the second argument is the function that is doing the transforming, which is the square root, and that's g, the second argument. When you do that, that will determine the probability density function of y. If you want the cumulative distribution function of y, then you throw in a CDF of y at the end, and it will come back and return the cumulative distribution function of y.